Hey everyone, I'm going to talk about 2.5 exponential functions. So in this section, it focused primarily on this particular type of function that you can see has a format like this right here. That f of x equals b to the x. So you could have it to where it's 3 to the x, 1/2 to the x. See, all these say your b has to be positive, okay? And it can't equal 1. So I could have anything as my base. Typically, b is referred to as the base. Okay. I could have like 10/3 to the x. Okay. So all these are different types of exponential functions. And you want to think for any exponential function you have, domain is always all real numbers, and your range is all positive. Now remember, these could switch. If you somehow do some transformation, then they might be different. Okay. So this first part here talks about graphing. You could plug in points, but as we've done with a lot of the previous sections, making a table is great and everything, but all of the homework questions you have to do will be about, you don't have to do point by point plotting or anything. It's just, can you pick out the right graph? Okay, so I would say use Desmos. And we can do that right now. But if you really wanted to make this table, one thing you could do is you could just do a -2, -1, 0, 1, 2, maybe 3. And then just plug it in 2 to the -2. So check with the calculator. And so you would do like 2 to the -2, which is 1/4. And then 2 to the -1 would be 1/2. And then 2 to the 0 would be 1. 2 to the 1 is 2. 2 squared is 4. 2 to the 3rd would be 8. And then you could plot these and see what they look like on Desmos. So you plot the points. So I'll show you Desmos in a second, but if I wanted to plot this graph, right, so at 0 we got 1, at 1 we got 2, at 2 we got 4, at 3 we got 8, at -1 we got -1/2, and at 2 we get 1/4. So it looks somewhat like this. And there is a asymptote at 0, a horizontal asymptote. So if we go over to Desmos, we can see that here. If I type in y equals 2 to the x, this is what our graph looks like. Okay. We see that at 0, it is 1. Okay. At 1, it seems to be, at 2, we get it to be 4. Okay. At 1, it's 2. At -1, it's a half. Okay. So for some of these other ones on here, like for instance, this one, it's 2 to the -x. So how will that look? So you could go through the whole plotting the table. Okay. So if you think about it, what it says here is whatever x you plug in, you're going to switch the sign and then evaluate, right? So what x value you plug in will switch signs. Right? So for instance, if I plugged in a +2, it's going to act like 2 to the -2. So this will give me a 1/4 here. And then 1 will act like a -1. And then 0, I can't really do anything. That negative doesn't change it, so I still get 1 there. And And if I check the negative of -1, which is like a +1, that'll just be 2. And then 2 to the negative of the -2, which is 2 to the second, which is 4. And then I could plot this. So let's see what it looks like. So -2, 4, -1, 2, 0, 1, 1, a half. So it looks like kind of like this, but it's kind of flipped, right? You think about it, when we switch the signs for the x value, it's kind of like we're flipping it over. So 2 to the negative x is the graph of 2 to the x reflected over the y-axis. Okay. And we kind of see that down here. And this summarizes it. We have 2 to the x for the blue line. We have 2 to the negative x, okay, which you can kind of simplify to this. If you want to think of it as 1/2 to the x, that's fine. Okay. So how they do that, in case you're curious, 2 to the minus x, I can write this as using some properties of exponents. 2 to the -1 times x. This will be 2 to the -1 all raised to the x. And then 2 to the -1 is 1/2. And that's how they kind of say these two are the same thing. Okay. And then this kind of summarizes that if you have your base is bigger than 1, it's going to rise as you go from left to right. You'll see as you go from left to right, what happens? It goes up. And we call this like exponential growth. You could think of it like that because it's growing. Your base is larger than 1, so it's going to grow. And here, when your base is between 0 and 1, we call this decay. As you go to the right, it's decaying. Okay. And they just summarize these properties here. One thing to note, if you have a regular graph, as in it's some number to the x, it's always going to pass through 0, 1. Now this might change if it's being shifted somehow. Okay. All the graphs are continuous, so no holes or jumps. The x-axis is the horizontal, as I said earlier, unless maybe you shift somehow. If you shift up or down, it's going to shift that the asymptote also. And then as we talk about this exponential growth, as x increases, your y will increase. That's what your b of x is, right? Because remember, f of x is like your y value. And then for decay, as x increases, your function will decrease. So use a calculator. So it wants you to really do these table of values, but I'm pretty sure we know how to do the table of values in sketching. So I would say get used to, get comfortable using Desmos to graph. So let's graph this on Desmos and see what we get. As I said, none of the questions on your homework are going to ask you to make a table. Okay. So let's type this in. So y equals 1 divided by 2, so 1/2. And then it looks like the next thing we have to type is 4 to the x. So we can put that 1/2 in parentheses if you'd like, to keep it the same format as the problem. And then 4 to the squared, like this. Right. So we see we have that here. So we see instead of going through 0, 1, it goes through what? 0.5 because you have that 1/2 in front. It's kind of shrinking everything. Remember, when you have something you're multiplying out in front, that's like you're shrinking the graph by 1/2, all the y values. Okay. Now, suppose I change this 1/2 to something else. I think the next one talks about putting the negative x, but we see what that happens. It's just going to reflect it over, and we can see that appear. If I do a different graph, oops. Okay. We see it just reflects over the y-axis. Now, one thing I want to just note, if we looked at some other things here, because you'll see here that they do some properties, but one thing I do want to talk about is, let's talk about exponential growth and decay. We'll get to that in a moment. And then it does some word problems here, which we don't really need to do all of them. And we're not doing regression. No exponential regression. But we will talk about compound interest, okay? So one thing I do want to say is that there's quite a few questions on your homework that have you graph various things. So let's look at a few on Desmos just to get some practice, okay? So some of the questions on Desmos, it wants you to match a graph with the picture, what it looks like. So if this is your function, so just type them in Desmos, match them up that way. That is the simplest approach. Okay. Now, in the past, there have been questions that will ask certain things. So for instance, if you have your one function, let's say if we have g of x is 8 raised to the x minus 8. Oh, whoops. So you want to make sure when you have something in the power, you keep it up in the power. So let's go back. Okay, it doesn't want to do that. Okay, so we're going to have to improvise. So put the parentheses here. So when you have to type something really long in your power, put parentheses around it. And you see it keeps that minus up there. And then we're going to close parentheses. So we have this for 1. And then it says our other function is f of x. So let's say it wants you to look at these two functions here. And how would you shift g of x? Or how would you get g of x from f of x? How do you shift it? So g of x is the purple. So we see that has x minus 8 instead of x. So remember, the x minus 8, think about what that does when you subtract something from the x. That's going to move it to the right 8 units. Okay. So as I said, you do have a few of these. Remember your shifts that we've talked about in the previous sections. And if you have trouble with some of these, just shoot me an email. But you do have quite a few, so just remember your shifting. Okay. And one of the harder ones is one where you have to think about what it looks like, okay? So for instance, we're just going to do some example here. So if you have your graph, all right, so let's say your graph looks like this. So you want to make sure you can identify some points it goes through. So let's say it goes through this point, 0, 1. And it goes through 2, 3. Just 2 points. You can, if you want to identify more points, that's fine. So let's say this is your f of x. So for this question, you'll see on your homework, you won't have any function given. It says, here's a rough sketch. What are these transformations going to do? So for instance, if we had, what is this going to do? So remember, if you subtract or add anything to the outside of the function, it's going to do it up or down. And so in this case, it'll do it, you'll go down by 2. Right, so let me just segment this out. Right. And then, so you would have to take this whole graph and shift it down 2. So you would pick the correct one that shifts it down 2. Okay. And then what if we had something like this? What would this function do now? So remember, when you're adding anything to the x, that's considered the inside, right? We talked about this transformation, so it's going to do the opposite. So this will actually go left 1 unit. So then the whole graph will shift left. So if you want me to kind of draw this in blue for the first one, you can think it's gonna look like this. Right? And if you want me to draw green for going left, it's gonna look like this, okay? It's moving to the left. And then you might have some combinations. So for instance, there could be some tricky ones, such as, suppose you have this. Right? 2 minus f of x minus 1. So always start where your f of x is. So think, if you're going to think about what this does, this piece here first will do what? It will go, remember it's minus 1, x minus 1, so that would be, right, 1. Okay. That's the first thing that will happen. And then we have this minus, and then we have this 2 in front. So one way to think about this, since it's written kind of weird, you can rewrite this as like that. So that minus in front looks more of like it's a reflection. So you're going to reflect over the x-axis. Okay. And then the third part is you're going to shift up 2. So once you see that, you can pick, because these are multiple choice, you're not going to have to draw anything, which is good. So just use your best judgment here. And if you do still have some questions, please shoot me an email. Okay. But most of the questions on your homework are graphing. Okay. What does it look like if you want to graph this? Okay. And then it'll be some solving. So we'll talk about how to solve some of the equations now. So just remember some of your exponent laws, okay, exponent rules. If you're multiplying two things with the same base, exponents add together. So if I had like 2 squared times 2 to the third, this would be 2 to the fifth. Well, I don't know why I changed to red. Right. And then when you divide, they subtract. The one on the top minus the one on the bottom. And then you have a power to a power, they multiply. So if you had 2 to the second to the fifth, this would be 2 to the 10th. Okay. And then this just distributes when you have a product and also when you have a division. So one thing to note, some of the homework questions will utilize these two properties here. If they have the same pace, the powers are equal. Okay. And if they have the same powers, the bases are equal. Okay. So You want to think, when do these apply? So all these work, right, for any positive number, and they can't be 1. If they're 1, it makes some of these invalid, okay? And you want to think, why does this part here, why does this contradict right here? A and B have to be positive. Okay, so if your base isn't positive, some of these properties kind of get thrown out the window. This next word here talks about a special base, base E. We see this a lot in compound interest, continuous compounded, right? So it talks about how you derive base E. So just think this wonderful expression here. It goes into how you derive this really long number, right? So if you take this at a very large x value, like if you plug in 1,000,000 here, you get something that will be super close to that value for, so this is E. So you see this special letter on your calculator sometimes, right? On Desmos as well. If we go to Desmos, you'll see that if you just type in, let's see, I don't know if you just type in E. Yep, see, E is already there. So it's on those special letters. And it talks you what does E look like when you graph it? You will have some questions on this. So you'll think E is just, instead of writing 2 point whatever, we just write E. It has the same look as some of the other exponential functions because it's close to 2 and 3. So it's going to have a similar shape as those. And it talks about exponential growth and decay here. K and C and K are the constants, okay? When you have time 0, so C is typically sometimes referred to as the initial amount or initial population, and K is the relative growth rate. Okay. They have an example of some bacteria here. Let me see if you have one of these on your homework, or if we should modify the problem to match your MyLab. So on your MyLab, what you have is, right, so you do have one. One will ask you to graph, okay? But one of them will ask you to estimate the population and write the equation, okay? So you can use the population one here and practice with this one if you'd like. So you'll see here that it says you need to write it like this, okay? So it says it has that relative growth rate, okay? So we want to think N0 is the number we start with. We start with how many? 25. So our equation would be, you can think it's like f of x, or in this case, f of t, because you can think big N, which is going to say is our f of t, and 25 is our initial amount, and then we have E, 1.1, well, not 1.1, whoops. Now on your homework, you might have to find this number here, and it's given to you. Just make sure you write it as a decimal, okay? So then if I want to know how many bacteria are present in 0.6 hours, what am I going to do? For T, I'm going to plug in that. So this is looking for and you just simplify that. So you can get your calculator, just type this in, see what you get. So this would be 57.42. And then if you wanted to do B here, this would be 3.5. So this would be 25 e to the 1.386. And then 3.5. So we get 3,196.7. So make sure you round accordingly. Okay. You could practice with this match problem here. So, and then it talks about decay. You won't really have any decay problems, so I'm not really going to talk about this half-life or anything like that with the radioactivity. If you wanted to practice this, you could, but we won't really be dealing with any half-life. And you see here's a picture in case you're curious. What does that mean? Okay. Yeah, so if you're curious about half-life, go at it. But typically, from a business standpoint, we're not going to be really doing much half-life. Okay. So the last stuff that we're going to talk about is some of these interest formulas. We're not going to do any regressions or compound interest. So make sure you understand these equations here. We have this first one, right? Compound interest. So P is the principal. R is your rate as a decimal. I can't stress that enough. It has to be a decimal. A is the value you get in the future. M is the number of times you're compounding. Okay, and T is the number of years. So let's look at this first one here. Suppose that $1,000 is deposited, so that's your principal. Right. It says it's 10%, so that would be your R. Remember, as a decimal, so it'd be 0.10. Okay. Compounded monthly. Monthly is 12 times a year. How much in 10 years? So that would be T is 10. So let's type in everything. So how much we get at the end is 1,000. And then 1 plus 0.1 divided by 12 raised to the 12 times 10. So just practice keying this in. Make sure you can key it in. You can use Desmos. So I'm going to just use my calculator here. So I get 2707. So around this much in your account. Right? So just make sure you can identify things. And then, now in some of the problems, you might have A, you might try to find P. Okay. So there's a lot of different things here that you could do. There's a lot of different scenarios that could happen. Okay. I think on your homework and maybe your mini project, you might have a question like where you have to find A. So just to look at the mini project if that is something that's stumping you. Okay. And then you have this continuous compounded. So it's very similar except for it's just A equals P e to the RT. You don't have any anymore because you're doing it continuously, means every day. P is the same. So in this one, you divest 1,000 at 10%. How many will you have in 10 years? So 1,000. So I don't know how much I'll have, but that's 1,000. And then 10%, remember as a decimal, and then 10 years. So make sure you key everything in correctly. So let's use Desmos for this to see what we get. So 1,000. And we have E. And then we're going to raise it to -10 times Let's see, it does it outside here, so when I remember, you got to put those in parentheses, okay? Times 10. All right. Oh, why did I put negative there? Did I put negative? That's my mistake. I meant to put dot because your rate is 10%. Okay. So we see we get around $2,718.28. So let me get the whole number. 2,718 and 28. So comparing the two, it looks like continuous will give you a little bit more money. And it will, because the more you compound your money, the more money you'll have. Okay. And you can do match problem there if you're curious. And that pretty much concludes. So, well, there's one or two questions I do want to stress. So I'm going to go back up here and kind of talk about them a little bit. So let me go back up to these rules that we talked about here. Now, there will be some questions where you might have to solve, okay, a few things. So, for any of these questions where you have to solve for x, some of the students have just used Desmos to get the result, which is perfectly fine. Okay. So, for instance, suppose I had a question where I had this. Well, we see they have the same base, right? So because same base, then powers are equal. So we get 2 minus 3x equals 7x minus 1. And then you want to solve accordingly. So we would add over my 3x, add over my 1 to the left side, and I get 3. Those cross out. And I get 10x. I'll divide by 10 to both sides. I get x is 3 over 10. Okay. So if they have the same base, you just equate the powers, okay? So the next part is what happens if they have the same power. Then you would do a similar thing, okay? So if they have the same power, so use those rules. So there is one that also seems to give trouble. If you have something like this. Like, when would this work, right? So you could do a few things here. Okay. So you think they have something in common, e to the negative x, so you want to factor that out. So I pull that out, so I have x. And then, kind of like from our previous practice in this unit, when I want to solve something by factoring, right? This or this can be 0. If I have two things that I'm multiplying to give me 0, either the first thing is 0 or the second. So if you think about it, can this ever be 0? It never works. Remember, e to anything can never be 0. It's always strictly positive. But what about x minus 9? Can this give me 0? Yes. So x would equal 9 here. So that's your result. Okay. And then the last one that I want to discuss is, it seems to cause some confusion sometimes. There's one tiny thing that you'll need to do at the beginning. So for this one here, you'll see you'll have e to the 9x minus 7, for instance, minus e equals 0. So, well, these have the same base, but they're not on opposite sides of the equal sign. So what I'm going to do is I'm going to add over e, and now I have the same base, right? Remember, if you don't see a power, it's understood to be 1. So now I can just say that 9x minus 7 equals 1. And go through the practice here. You get 9x equals 8 if I add over that 7. So I get x equals 8/9 for this result here. So do practice. Send me an email if you do have any questions. Okay. And don't be afraid to use Desmos to graph a lot of these things. Okay. Desmos is here to help you be successful in the course. Thanks again for your time.